Welcome to the HPI course Knowledge Engineering with Semantic Web Technologies. This is Lecture 1, Knowledge Engineering and the Web of Data, and today we want to talk about the web and how it becomes intelligent. This is part 5 of the first lecture. So, we have heard a lot about the World Wide Web, but today we are talking about something which is called a web of data, which means that the original web of documents, which was the World Wide Web, nowadays also has become a web of data because there are huge data resources that are accessible on the web, and they are accessible via standard and simple methods. So the web has become a huge decentralized database, or moreover a knowledge base, because the data that is represented in the web of data often also is connected to so-called ontologies, which represent the knowledge which is contained, the semantics which is contained within the data. So this is kind of machine accessible data. And of course this development started already with the beginning of the web, because Tim Berners-Lee already said right from the start about the World Wide Web that the web of human readable document is being merged with the web of machine understandable data. So the potential of the mixture of humans and machines working together in communication through the web could be immense. So moreover, from the beginning, the web was designed as an information space with the goal that it should be useful not only for human-human communication, but also that machines would be able to participate and help. But for machines being able to participate and to help, of course, they have to understand the information that is in the web. They have to understand the information in the document. They have to understand the information that is provided with the data. And we have seen that it's a really difficult task to extract the information and to grasp the meaning of the information in the document. So usually if you want to do this today, there are two different approaches. So the precondition is to be able to help for machines. Of course, they must understand the content. And we know already that understanding in our sense means the information has to be read and interpreted in the correct way, which means understood by machines. So the first way to do this is with the help, for example, of natural language processing technologies. So these are kind of traditional technologies that search engines on the web, for example, are using. But another approach, which is different but also can be complementary to the first approach, is the semantic web approach. So with semantic technologies, you will be able to annotate natural language web content explicitly with semantic metadata. And semantic metadata in this sense means it encodes the meaning, the semantics of the content, and it can be read and interpreted correctly, so understood in that case, by machines. So we have these two different approaches. First one tries to understand and to figure out with natural language processing technology, statistics and stuff like that, to understand or to grasp the meaning. And the other one is, okay, we can also endorse the natural language content in the web, it means the information in the web pages or also in the data, by explicit semantic annotation. So the semantic web approach means that the semantics will be made somehow explicit, so you can get access to the semantics. So I will show you again that understanding the content of information is pretty difficult, and also it depends, of course, of lots of factors that are defined in the context. So just take a look at this picture. So this was a headline several months ago, and it says, "Heisenberg can wait Saturday Night Football." So you might think now, so who is this guy Heisenberg? Yeah, so you have several possibilities, and also has the machine to understand what Heisenberg really is. So this process usually is called entity mapping or entity disambiguation, because Heisenberg can mean various things. So for example, Heisenberg could be somebody called Benjamin Heisenberg, he's a film director, or could be Jochen Heisenberg, who is a physicist, or can be Martin Heisenberg, who is a neurobiologist. Or, of course, one of the most famous Heisenbergs is Werner Heisenberg. He is a Nobel laureate and a physicist too. But as you might already know, because yeah, you know, it's several months ago, and Heisenberg, this was also a fictional character in a TV show, yeah, maybe this Heisenberg is nobody else than Walter White, fictional character in the TV show called Breaking Bad. So to distinguish and to decide what is really the unambiguous meaning of a natural language text, this process is called disambiguation. And disambiguation is the solution of linguistic ambiguities. Okay, so now let's consider this process solved. We know now that with this Heisenberg, Walter White, the fictional character, is meant to be. So what do we know about Walter White? So we know Walter White is kind of an entity, and we must determine somehow the meaning of it. What does it mean, Walter White? So we know that Walter White is kind of a fictional character. So it means this entity belongs to a given class, the class of fictional characters. So what is a fictional character? A fictional character is some kind of a person. So this is subclass of another class which is called person then. So what we have here, or what we can define here, is a relationship of entities and classes, and this of course is part of the meaning which is expressed, and this means that this entity called Walter White is a fictional character, so the entity belongs to a specific class. We can give a class membership, and we can also give something like a subclass relation. So person is the superclass of the subclass fictional character. So it means each fictional character is also a person, but not every person is also a fictional character. So you see, this is a directed kind of a relation. What we do now, right now, if we look at these classes and the entities, of course, the name of the classes right now, they are also given in natural language terms. So of course, we as humans know what are the properties, or should be the properties, of the entities that belong to that class, because we know what a fictional character is. The machine does not know it. The machine only knows that the entity Walter White belongs to a class which has a specific name, but the name of the class means nothing to the machine. The only thing the machine knows is that this class also is subclass of another class. So also without knowing what person really means. But also with this knowledge we can do a lot. So for example, we might know that Walter White is member of several classes. You see the classes here, for example, fictional characters from New Mexico, fictional school teacher, fictional scientist, fictional drug dealer, fictional gangster. You might wonder where I came up with all these classes. So these are the classes where the character Walter White is put in Wikipedia. So you have the Wikipedia page for this character, and this character belongs to several categories within Wikipedia, you know, the online encyclopedia Wikipedia, and there are lots of classes. So there are even more. So what we know about these classes, for example, is that we know they are subclasses of the overall class fictional character, and moreover we also know that fictional character is a subclass of person. So if we have exactly this relationship, what can we do with this now? So the first thing, of course, we know, because Walter White is one of these fictional character classes, and these fictional character classes are subclasses of fictional character, then we can deduce that Walter White might be also, or definitely is also, a fictional character. And we have another subclass relationship, therefore we can deduce that Walter White must be a person. And to deduce this knowledge is called, or this process is called, logical inference. So what we can do with these subclass relationships, we can infer other class relationships of this entity. And this is a rather small and a rather simple example of logical inference. We will see later in the lecture that you can inference much more complicated things. And this is something what we already have spoken about in the lecture, and we have called this is kind of implicit knowledge. And logical inference is able to make this implicit knowledge somehow explicit. And to represent this stuff or this knowledge, you need a mean, or you need some technique, and to do this you use so-called ontologies. So knowledge representations are also called ontologies, and these relationships that we are talking about here, they are so-called ontologies. So for example, you can also state that Walter White is a person, and you know about persons that persons must have a birthplace, a birth date, a mother or a father, and these in blue here are so-called relationships or properties between classes which are given within an ontology. So therefore, if you know that Walter White is a person, you might also infer that he must have some kind of a birthplace and also a birth date and stuff like that. So here's again another possibility for logical inference. But we will talk about this stuff later. The only thing I want to address now is that you see, if you are using knowledge representations, you will be able to infer or to deduce more knowledge, new knowledge that is somehow implicitly hidden in the already existing knowledge. And this is something terrific. So if you make this knowledge explicit in the semantic web or with semantic web technologies, then you create something which people about 10 years ago have called the semantic web, which is an extension of the current web in which information is given well-defined meaning, better enabling computers and people to work in cooperation. So there is a great article about the beginnings of the semantic web and the vision of the semantic web in the Scientific American, and you will see this, or you can read this article in the material that we give together with the course. So what is this semantic web? So in the semantic web, the meaning of information is made explicit. How is it made explicit? By formal, it means somehow structured, and standardized knowledge representation, which are ontologies. By doing this, it will be possible first to process the meaning of information automatically. And by doing this, we can relate and integrate, of course, previously heterogeneous data. And we can deduce implicit, so not evident, information from existing evident information, and we can do this in an automated way. Therefore, the semantic web is nothing else but a kind of global database that contains somehow a universal network of semantic propositions, of semantic information. And with the semantic web, there's lots of technology that has been standardized by the W3C, and you can see this here in this so-called semantic web technology stack, or previously it was called layer cake. And you see here several layers, starting with the lowest layer where we have all the web platform technology, going over formats, going over exchange formats, modeling representations, knowledge representations, and logic, and all of this. And here you see somehow a summary of all the technologies we will talk about in the course of this lecture. So, in the next lecture, I will give you a brief introduction into the single layers and stages of this semantic web technology stack.